Good day! With this video lesson, we're going to discuss the topic Understanding Estimation of Parameters under your Probability and Statistics. Our lesson objectives. At the end of this lesson, you are expected to identify the length of a confidence interval, computes for the length of the confidence interval, computes for an appropriate sample size using the length of the interval, and solves problems involving sample size determination. So let's have some review with this figure 1, your normal distribution curve. So we have learned about the properties of the standard normal distribution in the previous lessons that we're done dealing with. So let's try to recall that a standard normal distribution is a normal probability with a mean of 0 and a standard deviation of 1. At the horizontal base of the curve, we find C values. So please do take note of this, that there are only 6 C scores allowed in every normal curve. The C value or the C score is the number of standard deviations that a particular x value is away from the mean. That's why in every mean here, there is a corresponding standard deviation here that we can map in each of the probabilities under your normal distribution curve. So here in figure 1, it shows the area in each region. So the area under the curve is 1 or 100%. So your total area of this normal curve will be equal to 1 or 100%. 1 as a total area or 100% probability. The proportion of the area between 1 standard deviation unit below the mean and 1 standard deviation unit above the mean is 68%. As you can see here, so there is a 68% here. The area under the part of a normal curve that lies within 2 standard deviation, about 95%. So there is a 2 standard deviation here. So there is an involvement of 2 standard deviation. Then the area under the part of this normal curve is 95% if we consider these 2 standard deviation. And with 3 standard deviation here, then it's about the area is 99.7%, as you can see in this figure. So for our lesson proper, in statistics, population parameters cannot be measured, or there is no way in finding the exact value of population parameters. In inferential statistics, conclusions or descriptions can be made about the population using the samples derived from the population itself, because we are only subjecting in our research. For example, we only get a sample from that population, and this sample will be subjected to our research, and this sample will represent the entire population. So with this figure, it's about weight of rabbits, total population mean. Here in this figure, no, so we get a sample 1, which your sample size is 30 and your sample mean is 3.2 pounds. In your sample 2, we have n, which is equal to 65, or your sample size is equal to 65 and your sample mean is 4.2 pounds. For your sample 3 here, your N or your sample size is 120 and your sample mean is 5.7 pounds. So as we observe here, when your sample size increases or when the sample that we subject in your research, for example, increases, so there is a bigger possibility that your sample mean will also increase because when your N or your sample size increases, definitely or most probably that your sample mean will also increase. It can be derived from the figure that the sample mean can only be used in describing the sample population. Yes, it is, but we cannot use this one to describe the total population. So we just only use this one for us to describe the sample population. But we cannot use the data that we get from the sample 1, sample 3, and sample 2 and 3 for us to describe the total population. But we can use this one to describe the sample population. In order to describe the total population, we use confidence interval. No, for us to describe the total population of this one, no, so there should be an involvement of your confidence interval. So what are these values? No, so it can be 99%, your 95%, or 90. So we commonly the most commonly used value of your confidence interval is 99%, 95%, and 90%. For definition of terms, the confidence interval is defined as to be the range of values used to estimate a parameter. So we simply use your confidence interval for us to estimate a parameter. It is also called interval estimate. And say another term for your confidence interval is your interval estimate. The confidence level of an interval estimate of a parameter is the probability that the interval estimate contains the parameter. So we simply set a confidence level for us to see, or we simply assume that the parameter will fall on this confidence level or interval, I mean. It describes what percentage of intervals from many different samples contain the unknown population parameter. So for example, number 1, the age of the grade 1 pupil is any value between 6 years and 7 years. So there is a set parameters here and we assume or we estimate that the age of the grade 1 pupil will fall in between of these two ages. For example, number 2, a researcher may wish to be 99% confident that the interval contains the true population mean. If a researcher wishes to be more confident, such as 99% confident, then the interval must be larger or wider. So there should be a wider interval if we are looking for or if we wish us to be more confident. For instance, a 99% confidence interval for the sample mean. To be more confident that the interval contains the true population mean, and for us to be more confident that within the interval the true population mean will fall, so your interval should be wider or larger. one must the interval wider. So again, for us to be more confident, no, as a researcher, and if we assume that the true population mean will fall on the set interval, then our interval should be more larger or must be larger or and wider. So it can be larger or wider. So if we try to look on the normal curve, no. So your confidence interval should be wider, but on a value, it must be larger. Remember, in determining an interval estimate or a confidence interval, a degree of confidence expressed as a percentage such as 95%. So a while ago, I said that the most commonly used value for this confidence interval is 99%, 95%, and 90%. That the interval contains the true and fixed parameter is made. That is, if we collect several random samples and then calculate a confidence interval from each sample, these confidence intervals are constructed wide enough so that 95% of them contains the true population parameter and 5% do not. So this 5% will serve as your alpha or level of significance. This will be the maximum percentage of error that a researcher wants to meet. The value of 95% is also known as the confidence level. So for this slide, we're talking about your interval estimate of population mean. So your confidence interval of your population mean mu when population standard deviation sigma is given. So here there is a formula for the confidence interval of the mean for the specific value of your alpha, which is your level of confidence or level of significance. So when we say alpha again, when we say level of significance or level of confidence, this will be the maximum error that a researcher wants to meet in their researches. Here in this formula, no, so there is a parameter being given. Here there is a uh, minus and addition, subtraction and addition here between your population, I mean your sample mean and your C sub alpha over 2 multiplied by your sigma over your square root of your sample size n, wherein we always assume that your population mean will fall on your lower limit and your upper limit here. So as you can see here, so there is an alternative portion of this one, no? Meaning to say that this portion of the C sub alpha over 2 multiplied by your sigma over square root of n is the counterpart of your E here. So your E here will be equal to your C sub alpha over 2 multiplied by sigma over square root of n or your sample size. So that will be the equivalent value of this E. So that's why there is an or here, because your sample mean x bar minus E, which is the equivalent value of your C sub alpha over 2 multiplied by sigma over square root of n, should be less than to your population mean, less than to your x or your sample mean plus your E or your maximum error. As you can see here, there's a parameter, and we assume that your population mean will fall in between your lower and your upper limit. So for your lower limit, there's a formula here, which is your sample mean minus your C sub alpha over 2 multiplied by sigma over square root of n, which is your sample size. So that will be your LCL, or the lower confidence limit. And for your upper confidence limit, so we have your formula that your x bar plus your C sub alpha over 2 multiplied by sigma over square root of n. So that will be your UCL, or the upper confidence limit. So here there's a legend here. So for us, or that will serve as our guidelines, no? In different symbols involved in the given formula. So your x bar, that will be your sample mean, your C critical value. Your sigma is your population standard deviation. Your n is your sample size. Your mu is your population mean. Your alpha here will be equal to your level of confidence or level of significance. Then your C here is your C sub alpha over 2 will be equal to the margin of error. So as you can see in this graph, your alpha over 2 will represent the area of your critical region. No? This will serve as your critical region, wherein if your C computed value, or your T value, will fall on your critical region, then you're going to reject your null hypothesis. And if your computed C or your computed T will fall here in your non-critical region, in this part from in this area, wherein your area will be equal to your confidence interval, that will be equal to 1 minus your level of confidence or level of significance alpha, because your level of confidence plus your confidence interval is equal to 1. So if we're asked to find the value of the confidence interval, so we need to subtract your alpha to 1. So that will be the value of your confidence interval. So if your computed C and your computed T will fall on this region, the non-critical region or the acceptance region, then you're going to accept your null hypothesis. So that will be the case for this one. Here is the list of the common confidence interval and their critical value. So a while ago, I said that the most commonly used values for your confidence level or your confidence interval is 90, 95, and 99. So since your confidence level or your confidence interval plus your alpha here will be equal to 1. That's why whatever, no, if we convert this 90% to decimal, that will be 0.90 plus 0.10, so that will be equal to 1. So if we convert this 95% to decimal, that will be your 0.95 plus 0.05, so that will be equal to 1 also. So if we convert this 99% to decimal, that will be equal to 0.99, no? Plus your 0.01 here, so that will be equal to 1. Now, your alpha over 2, so we just simply divide this 0.10, so that will be equal to 0.05. 0.05 divided by 2, so that will be 0.025. 0.01 divided by 2, so that will be 0.005. Now, looking for the values of your critical value using your C table, no, wherein we're asked to find the value of your C sub alpha over 2. Then the values for this one, no, for your C sub alpha over 2. So if we're looking for the two values for your critical value, no, we're going to subject both your left and right side of your normal curve, because we're considering both sides of your, or this will serve as a two-tailed test. No, once you're dealing with alpha over 2, meaning to say you are dealing with two-tailed tests, and we subject both your left and your right side of your normal curve in our research. For the critical value for your C sub alpha over 2, when your alpha over 2 is 0.05, so that will be 1.645. Then for 0.025, no, our critical value is 1.96. Same thing with your 0.05, that will be 2.576. So it is important for us to memorize these three values, no, and their critical value. Why? Because these are the most commonly used values for your confidence interval. So even if without your seed table, if we memorize these values, no, right away we can give your critical value with the given value of your confidence interval in the given problem. So here there is so the table shows the three commonly used confidence levels and their associated values of C sub alpha over 2. So for instance, no, if the confidence interval is 1 minus alpha, so definitely that is 1 minus alpha because alpha plus your confidence interval is equal to 1. So whatever the value or the uh, resulting value, once we subtract your alpha to 1, that will be your confidence interval. Then your alpha now is 0.10 because if that's why your confidence interval now is 90%, then your alpha is 0.10, or meaning say that will be 10%. So if we add these two values to make it 100%. Now your alpha over 2 now is 0.05. So we just simply divide this alpha into 2 if we subject both sides of your normal curve because we cut into two equal values. And C sub alpha over 2 is equal to 1.645. The resulting confidence interval estimator is called your 90% confidence interval estimator of your mu. So in our last slide, no, we assume that your population mean will always fall in between your lower and your upper confidence level or interval. No, that's why we assume that this mu or your population mean will fall in between your upper and lower confidence uh, level, your LCL and your UCL. So for the definition of term, so the maximum error estimate is the maximum of parameter and the actual value of the parameter. It is the term E, which is equal to C sub alpha over 2 multiplied by sigma over square root of n. So there is a value of C sub alpha over 2 here multiplied by sigma over square root of n. Same thing with the left side of this normal curve. So at some point here, no, the value of this area will be equal to your C sub alpha over 2 over square root of multiplied by sigma over square root of n, or your sample size. Same thing with this side, no, same value. That's why we subtract and add to your population, to your sample mean, to make it your uh, lower confidence level and your upper confidence level. So we just simply subtract this C sub alpha over 2 multiplied by your sigma over square root of n to your sample mean, no, for us to have the value of your lower confidence level and your upper confidence level. So for the specific value, so C alpha is equal to 0.10, then 90% of the sample means will fall within this error value on either side of the population mean as shown in figure 2. So for our examples, no, for number 1, so let's start with this example number 1. So from a normal distributed population, so we assume that your population is normally distributed. So we took a simple random sample of 500 students with a score of 85 on the math section of the National Achievement Test NAP. Suppose the standard deviation of the population is 2.8. So what is the estimated population mean of 95% confidence level? So your step number 1 is to list down all the given values. Your n is 500, your sample mean is 85, your population standard deviation is 2.8, and your confidence level is 0.95. So we just simply convert this percent to decimal, or we just simply divide this 95% by 100, no, that will be equal to 0.95. Your step number 2 is to assume that your population is normal, then your sample is randomly selected. So there are two conditions that must be met, no? That your population is normal and the sample is randomly selected. For step number 3, so since the 95% confidence interval is to be used, then for us to compute for the value of your alpha, so your alpha now will be equal to 1 minus your CI, or your confidence interval. So that will be 1 minus 0.95 or 0.05. So since we're dealing with the two-tailed test, so we need to divide this 0.95 by 2. So your alpha over 2 now is equal to 0.025. Now, a while ago, I said that it is important for us to memorize, no, the values of your the value of the most commonly used confidence interval and their corresponding value of your C critical values, no, because even without your C table, we can give the value of your critical value as long na as long that we know, no, the value, or how we compute for the value of your alpha over 2. And if we know how to compute for the value of alpha over 2, then we can give a value of your critical value by simply memorizing it, no? So there are three most commonly used values that will be your 90, 95, and 99, and their corresponding critical values of C sub alpha over 2. So for your step number 4, no, so we're going to deal with this upper and lower confidence level, no? The UCL and the LCL, and we assume that your population mean will fall in between your lower and your upper confidence level. So we simply use this formula, your x bar minus your C sub alpha over 2 multiplied by sigma over square root of n. Same thing with this one, no? For your upper confidence level, no? We just simply add your C sub alpha over 2 multiplied by sigma over square root of n to your uh, sample mean x bar. Now, with the given values, we just simply substitute the given values for this formula. That will be 85 minus 1.96. That will be your critical value if your alpha over 2 is 0.025, or your confidence interval is 95%. Then the resulting value for this portion is equal to 0.245. We just simply subtract it to your 85. That will be 84.755. On the upper confidence level, we just simply add this 1.96 multiplied by 2.8 over square root of 500 to 85. Unlike to your lower confidence level, no, we subtract this value to your 85. Now, for your upper confidence level, we just simply add this one to 85. So that will be equal to 85.245. Now, if we're going to plot this one using your normal curve, this 84.755 and 85.245 will represent this portion, no? So this portion will be equal to your 84.755 and 85.245. That will be your lower and upper, no, confidence level. So our conclusion here, no, we are 95% confident that the population mean occur on the math section of the knot lies between 84.755 points and 85.245. So meaning to say, the scores of the 500 samples that we get from the knot, no, their score will fall, no, between 84.775 points and 85.245 points as we compute and we apply the margin of error for the lower and upper confidence level. So for example number 2, So whereas to find the 90% confidence interval of the population mean for the scores of grade 11 students Interlock Province High School, a random sample of 30 grade 11 students is shown. So we only subject these 30 grade 11 students in this experiment. So have your 20, 20, 21, 23, 14, 11, 22, 22, 12, and 11. So there are 30 scores here from the 30 grade 11 student. So for our solution for step number 1, so find the mean and the standard deviation for the given data. So we knew that your sample mean will be the average of these 30 scores. We just simply get the total of these 30 scores and we divide it by 30. So whatever the resulting value, that will be your sample mean, or 17.933 here. For the value of your sample standard deviation here, your square root of summation of x minus x bar square over your n minus 1. So our resulting value is 4.185. So from our previous lesson, this formula is available on how we compute for the value of your sample standard deviation s. Now, for your summation of x, that will be 538 and your n is equal to 30. So if we divide this 538 to 30, so our resulting value will be equal to 17.933. So for step number 2, no, your population is normal, so there are two conditions that must be met. No, your population is normal and your sample is randomly selected. So we need to satisfy these two conditions that we're going to meet with this problem. So for step number 3, since the 90% confidence interval is to be used, meaning to say your alpha now is equal to 0.10, and once we divide this alpha by 2, that will be 0.05. Now again, it is important for us to memorize the value of the critical value of C with the given value of your confidence interval. So if your confidence interval is 90%, then your critical value for this one is 1.645. So for step number 4, once we apply this again, your formula for your lower and your upper confidence level, so we just simply subtract your C sub alpha over 2, subtract and add, your C sub alpha over 2 multiplied by sigma over square root of n to your sample mean x bar. So we just simply substitute the given values for your lower and upper confidence level. That will be 17.933 minus 1.645 multiplied by 4.185 over square root of 30. So here, in your upper confidence level, we just simply add the values of your C sub alpha over 2 multiplied by sigma over square root of n. So our resulting value is 16.677 and 19.189. So this will be your lower and your upper confidence level. So if we're going to graph this one, this will be your 16.677 and this will be your 19.189. So in this portion, that will be your 90% confidence interval, Once we know, that will be your alpha over 2 here, that will be 0.05. So there is a 0.05 here. So there is a typo here dito. So there's a lapses of 0.05 in this side. So there should be a 0.05 in this side because we subject both your left and your right sides of your normal curve. Now, our conclusion now, thus one can be 90% confident that the population mean score is between 16.677 and 19.189 based on the sample of grade 11 student. So meaning to say, the population mean of score, it will fall in between these two values. and that is 90% confident. Now, for the interval estimate of the population proportion, now let's deal first with the definition of what is a proportion. Proportion is a fraction expression where the favorable response is in the numerator and the total number of respondents is in the denominator. So the basic operation involves division. So therefore, the result is a decimal value that can be expressed as percent. So it can be in percent or it can be in decimal. So the formula for computing a large sample confidence interval population proportion P is this formula. So we're now dealing with the population proportion. No. So your P hat now, that will be your sample proportion, minus your C sub alpha over 2 square root of your P hat, Q hat, your P hat and Q hat. So if we add this P hat and Q hat, it should be equal to 1 over your sample size N less than your P, which is your population proportion, and your P hat plus your C sub alpha over 2 multiplied by square root of P hat Q hat over N, or it should be P hat minus E. This will be your maximum error E less than your P. That will be again your population proportion less than to your upper limit here. No. Your XD here is the number of observation in a simple random sample, and your N is the sample size. So N is still your sample size. So remember, proportions can be obtained from samples or populations. So we don't limit these proportions only for your samples, but it can be obtained, no, both from your samples and or your populations. So for instance, the percentage expression 78% percentages are prepared when reporting frequencies of subsets of population, but in computing percentage are first converted to proportions in decimal form. So this will be a good example of these proportions. No? So this statement is a good example of your proportions. So for examples under this topic, so for example number 1, so a sample of 350 nursing applications including 140 women. No. Find the 95% confidence interval of the true proportion of women who applied to the nursing program. So for step number 1, you need to list down all the given values for n or your sample size. That will be 350. For your x, that will be equal to 140, and your confidence level is 0.95. So we just simply convert this 95% to decimal, so that will be equal to 0.95. So for step number 2, sample is randomly selected. Conditions for a binomial experiment are satisfied. So there are conditions that must be two conditions that must be met. No, so these are the two conditions that must be met. So step number 3, your C sub alpha over 2 now. So we're asked to find the value of your C sub alpha over 2. Your alpha is 0.05, no? From 1 minus 0.95, then your C sub alpha over 2 is equal to 1.96, or your critical C value from this table. That's why it is important for us to memorize this table, because even without this table, as long that there is a given value of your confidence interval or confidence or your alpha, no, alpha over 2, then you can easily, or we can give right away, no, your C sub alpha over 2 without a table, no, if we memorize it. So for step number 4, to compute for your P hat, your P hat is equal to X over n, and your q hat is equal to 1 minus p hat, because your p hat plus q hat is equal to 1. So your p hat now is equal to 140 and over 350, that will be 0.4. Your q hat now is equal to 0.6. So if we substitute this q hat and your p hat in the given lower and upper limit, no, dealing with your population proportion in this given formula, no. So we just simply substitute the given values for this given lower and upper uh, proportion limit here, no. So that will be 0.4t plus or minus for your lower and upper limit, minus for your lower and addition for your upper limit. So minus 1.96 square root of multiplied by square root of 0.4t multiply 0.6t all over your 350. So this will be your lower limit, or that will be equal 0.349 or 34.9%. For your upper limit here, no, so that will be equal to 45.15%. So there is a typo here. This will be addition, not subtraction, between your operation between your 0.4t and 0.451. No. So once we apply these values for your lower and upper limit, so your lower limit is 34.9% and your upper limit is 45.15%, and we apply your alpha over 2, which is equal to 0.025, then that will be 95% confidence interval. That is 95% confidence interval. Now, your conclusion, one can be 95% confident that the percentage of the applicants who are women is between 34.9% and 45.15%. So meaning to say that the percentage of the applicants who are women will fall, no, between your 34.9 and 45.15%. It should be in between of these two limits, or in between your lower and your upper limit. For example number 2, for population proportion, so the municipal government of Camilling-Tarlac wants to estimate the percent of the citizens who are willing to pay for mandatory drug tests. In a survey among 300 citizens, 210 of them are willing to pay for the drug test. Construct a 99% confidence interval for the proportion of the citizens who are willing to pay for the mandatory drug test. So for step number 1, so we need to list down all the given values. Your n is 300, your x is 210, and your confidence level is 0.99. We just simply convert this 99%, no, into decimal. Your step number 2, we need to, these are two conditions that must be met. Your sample is randomly selected. Conditions for a binomial experiment are satisfied. For step number 3, we need to look for the value of your C sub alpha over 2, or the C critical value. No? First thing to do is to find the value of your alpha. Your alpha is 0.01. That will be from 1 minus 0.99. Now 0.01, no, that will be your alpha. So from this table, our critical value is 2.576. So this will be the critical value that we're going to use for our lower and your upper limit. So for step number 4, for us to compute for your p hat now is still x over n, and your q hat is equal to 1 minus p hat. Your p hat is equal to 210 over 300, or 0.7t. Q hat is equal to 1 minus p hat, or simply 1 minus 0.7. So that will be equal to 0.3. So there is a zero point 0.7 and zero point 0.3 here as a value of your P hat and your Q hat. So we just simply substitute this given formula for the margin of error for this formula. And we assume that your population proportion P will fall in between your lower and your upper limit. So we just simply substitute the given values for your lower and your upper proportion limit in this part. So our resulting value for your lower limit is 63.2% and for your upper limit is 76.8%. Now, once we apply your alpha over 2, then the value of this is 0.05. That will be 0.10 divided by 0.01 divided by 2. So that will be equal to 0.005. And your confidence interval is 99%. So our conclusions, therefore, one can be 99% confident, that the percentage of the citizens who are willing to pay the mandatory drug test is between 63.2 and 76.8%. So the percentage of the citizens is definitely will fall in between your 63.2 and 76.8%. So will fall in between here of these two values. So for computing for an appropriate sample size using the length of the interval, so the sample size when estimating the population mean n, your n now is equal to c sub alpha over 2 multiplied by sigma over your e, that will be your margin of error, e here, square. So this will be the formula in finding the sample size or the value of your sample size when estimating the population mean. Where this will be your legend. No. Again, your n is your sample size, your c sub alpha over 2 is your c critical value, and your population standard deviation is your sigma. So examples for these in finding the value of your n. So for number 1, researchers are interested to estimate the mean cholesterol level of particular variety of monkey. Researchers would like their estimate with 2 milligram per dl of the monkey's blood at 95% confidence level. Previous studies suggest that sigma or your population standard deviation is 60 mg per dl. Obtaining monkeys is expensive and time consuming. What is the minimum number of monkeys would they need to generate satisfactory estimate? So using these values, we're looking for the value of your sample size. Now, for step number 1, your population standard deviation is 6, your E or your error is 2, your confidence level is 0.95, and your C sub alpha over 2 is 1.96. Dealing with this confidence of interval using your table, so that will be your 1.96. That's why it is important for us to memorize the most commonly used value of your confidence level plus their corresponding value of your C critical values natin. Here, step number 2, we just simply substitute the given values here for the formula for n. So that will be 1.96 multiplied by 6 over 2 square, or simply equal to 5.88 square, or simply 34.574. So in this case, if the first decimal is 0.5 or above 0.5, so we're going to round up because it is approximately equal to 35. Because there is no sample size which is equal to 0.5. For example, there is no monkey which is equal to 0.5. So we cannot say that there is a 0.5 monkey. So it should be 1 monkey. That's why we need to round up. Conclusion: 35 monkeys are needed to be able to make the research successful at 95% confidence level. So we just need a 35 monkeys to make this research successful at 95% confidence interval. So it can change, no, the number of monkeys can can move or decreases or increases. It will be dependent, no, on the confidence level that we're going to use, or what value, no, we're going to set as a value of your confidence interval. For example number 2, you want to estimate the mean gas price in your town to 25 cents. Local newspapers report the standard deviation for gas price in the area is 55 cents. What sample size is needed to estimate the mean gas prices at 95% confidence level? So your step number 1, you need to list down all the given values. Your population standard deviation sigma is equal to 0.55, your margin of error is 0.25, your confidence level is 0.95, and using your table, your C critical values is 1.96 if your confidence level is 0.95. For step number 2, we're going to substitute these given values to the given formula, which is your N is equal to C sub alpha over 2 multiplied by sigma over E square. So that will be equal to 1.96 multiplied by 0.55 over 0.25 square. Or simply, if we simplify this one, that will be equal to 4.312 square, or simply 18.59 again, if the first decimal is greater than 5 or equal to zero point 0.5, no? Then it should be round up. So we need to round up this one because there is no such thing as zero point 0.5 gas price. So it should be in a whole decimal, in a whole number, I mean. So our conclusion, your 19 gas price are needed to be able to make the research successful at 95% confidence level. So we need 19 gas price to make this research successful using your 95% confidence level. So your sample size when estimating the population proportion, your N is equal to P hat multiplied by Q hat multiplied by C sub alpha over 2 over E square. So let us remember, no, in computing the sample size for estimating a population proportion, there are two situations to bear in mind. So first thing, if there is an indication of value of P hat, apply it for P hat and Q hat is equal to 1 minus P hat. For number 2, assign 0.5 for the value of P hat if no approximation is known, and it will obtain the largest possible sample size. No? So if there is no value given for P hat, you should assume, or we need to assume, that your P hat is equal to 0.5. So there are two situations that we need to take note with this one. So if there is a value of your p hat, then we use this formula q hat is equal to 1 minus p hat. If there is no value for your p hat, then we assume that your p hat is equal to 0.5. Or we need to set your p hat to be equal to 0.5. For example, number 1 under this topic, a researcher wishes to estimate 99% confidence the proportion of junior high school teachers with laptop computers. A previous study shows that 48% of those interviewed had laptop computers. The researcher wishes to be accurate within 3% of the true proportion. So find the minimum sample size necessary. So for solution step number 1, so we need to list down all the given values. Your alpha is 0.01 because 99%, we're dealing with the 99% confidence interval. So we subtract this 0.99 to 1, therefore your alpha is 0.01. Then if we divide this alpha by 2, then the critical value for this one is 2.576. Your p hat here is 0.48. So that will be your uh, population proportion, or I mean the sample proportion. Then q hat now is equal to 1 minus 0.48. That will be equal to 0.52, and your E now is 3% or 0.03. So if we substitute these given values to your step number 2, then the resulting value for N is equal to P hat multiplied by Q hat multiplied by C sub alpha over 2 over E square. So we just simply substitute 0.48 multiplied 0.52 multiplied by 2.576 over 0.03 square. Then your N now is 1,840.32, or simply is equal to uh, 1,841. Now, in this case, no, there is no scenario wherein that you need to consider, no, that your first decimal is zero point 0.5, no, as long that is more than or there is any excess, no, for example, in this part, 1,840, so there is an excess of 0.32 in 1,840 to make it 1,841. So it is approximately equal to 1,841 because it 1,840.32 is greater than 1,840. Once it is less greater than, no, so we need to round up, no, to the next whole number. That is 1,841 junior high school teachers to interview and to make this research successful. For example number 2, how large a sample should be surveyed to estimate the true proportion of the senior high school student who surfed the internet in a day within 4% with 95% confidence? So again, for step number 1, you need to list down all the given values. Your alpha is 1 minus 0.95, that will be 0.05. And your critical values for this one, for 0.0025 as your alpha over 2, so that will be 1.96. Your E is 4% if we convert to decimal, so that will be 0.04. So take note that there is no prior knowledge of p hat. We assign the values of p hat which is equal to 0.5. So there is a typo here. It should be 0.5. Again, if there is no given values for your p hat, we need to assume or we need to set a value of your p hat which is equal to 0.5. And your q hat is automatically equal to 0.5. So the sample size obtained by using these values will be large enough to ensure the specified degree of confidence. So for step number 2, we need to substitute the given values for your step number 1. So that will be n is equal to p hat q hat multiplied by c sum alpha over 2 over e square, or equal to 0.5 multiplied by 0.5 because your p hat is equal to your q hat multiplied by 1.96 over 0.04 square is equal to 600.25, or approximately equal to 0.1. Again, 600.25 is greater than 600. So we need to round up this one to the next full number. That is 601. Our conclusion, 601 students to us will serve the internet in a day. So we need 601 students to make this research successful. In solving problems involving sample size determination, if the sample statistic is normally distributed with respect to the central limit theorem, sample size can be estimated using the following steps below. So we apply your central limit theorem if your n is a large sample, meaning to say it should be equal to 30 or greater than 30. So steps in solving the sample size, determine the confidence level. For number 2, determine how much error E is acceptable. E is the maximum error of estimate. Then for number 3, S, determine the population standard deviation if unknown, estimated it. And for number 4, we need to solve for the sample size. For examples under this topic, so for number 1, a principal wishes to estimate the average number of hours senior high school students spend doing homework per week. The standard deviation from a previous study is 4.5 hours. How large a sample must be selected? He, he wants to be 95% confident of finding whether the true mean differs from the sample mean by 2.1 hours. So for step number 1, we're going to list down all the given values for confidence level. It is 0.95, your alpha is 0.05. Then it is from 1 minus 0.95 for your confidence interval. Then your C sub alpha over 2 or your critical values for this value of alpha is 1.96 from this table. Now, from this table, it should be 1.96. So there is a typographical error here in making this box, no? So this will be a typo. So our values for this one is 1.96. So for step number 2, we need to look for the value of your maximum margin of error, which is your E, and that is given to our problem. Your E now is equal to 2.1. Your sigma is 4.5 for your step number 3, and for your step number 4, we need to substitute all the given values in the formula. So N is equal to C sub alpha over 2 multiplied by sigma over E square is equal to 1.96 multiplied by 4.5 over 2.1 square. That will be equal to 17.64. Then it is approximately equal to 18 because there is no such thing as 0.64 student. That's why we need to round up this one to the next whole number. Our conclusion, to be 95% confident that the estimate is within 2.1 hours of the true mean, the principal needs sample size of at least 18 students. So we need at least 18 students, no, to make or for us to be 95% confident. For example number 2, a department store is interested in the charges made by the credit card customers. The general manager of the department store would like an estimate of in purchase amount, amount for its credit card customers that is within 500 pesos of the actual population mean. For 99% confidence level, how large a sample is necessary if the population standard deviation is estimated at 3,800 pesos. So again, for step number 1, you need to list down all the given values. Your confidence level is 0.99. Then your alpha is equal to 0.01 from 1 minus 0.99. Your C sub alpha over 2 now is equal to 2.576 from your given table here. So that will be 99, your alpha is 0.01, then your critical value is 2.576. For step number 2, your E is 500. Step number 3, your population standard deviation is 38. Then we need to substitute the given value for the given values now to the given formula in your step number 4. Then your N now is equal to 2.576 multiplied by 38 all over 500. So whatever the resulting value here, it should be raised to 2. Then the value is 383.282 and approximately equal to 384. Meaning to say, for us to be 99% confident that the estimate is within 500 pesos of the true mean, the general manager needs sample size of at least 384 credit card customers. Remember, no, when determining sample size, we always round up the resulting value to the next whole number. For instance, if n is 57.3, round it up to 58. So we need to take note of this. We should remember that when determining sample size, we always round up the resulting value to the next whole number. For activity number 1, we need to complete the solution of the problem by providing the necessary information. It is just like a fill in the blanks. So you need to fill in the given the values, the needed values for the blanks in this problem. Then for activity number 2, where you are asked to solve the following problems relating to estimation of parameters. For number 1, in a graduate teacher college, a survey was conducted to determine the proportion of the student who wants to major in mathematics. If 378 out of 900 students said yes with 95% confidence, what interpretation can we make regarding the probability that all students in the teacher graduate college want to major in mathematics? So we need to follow the steps. So you need to follow the procedures in your solution. So thanks for watching. If you want to like, comment, share, and subscribe, please do so. I'm Arben Enriquez, your subject teacher for probability and statistics.